Now we're going to take everything that we've been learning about conversions and apply them to drug conversion problems. It's just going to be all the same as what we've been doing, except there's going to be a little bit more information given to you in the problem, like a dosage or a drug concentration. So let's go ahead and start with how we go to approach these problems. Many time ratios are given to you, and when a ratio is given to you, realize that it can be used as a conversion factor. Sometimes it says this to that or this in that. Anytime that a relationship is given to you, realize you can convert that relationship to a conversion factor that is a fraction with the number and the unit that goes with that number on one side and the other number and a unit that goes with it on the other side. And then flip that fraction as you need in order to get unit cancellation. In doing a drug conversion, it's really just the same as any other conversion. The only thing that you might have as a little helpful thing here is that you always start with your dosage. It gives you the right units when you finish if you start with your dosage. One thing that also will help you is look at what the question is asking for. Put the answer, the units that you need in the answer, on the right side of the page, your dosage on the left side of the page, and that might help you be able to think through how do I go from the dosage to the units I need to get the correct answer. In the text of your problem, you will often find that there are concentrations of medicines given to you, and you want to convert those into conversion factors. So if it says 100 milligrams per 2 milliliters, you know you can write a fraction that is 100 milligram over 2 milliliter, and you can flip that fraction as needed. You will also be using metric conversions, and an example would be going from microgram to milligram. And I know, just because I've been using micrograms and milligrams so much, there are 1,000 micrograms in 1 milligram. If you do not know that relationship, stick with the prefix method of going from one unit to another in the metric system. Now, in your dosage, you will often see a kilogram in the denominator, or it will say a particular amount per kilogram. That per kilogram, or sometimes it's per pound, means per mass of that person. So in your calculations, you have to eliminate that unit by multiplying by the mass of the person. Realize if the dosage is given in per kilograms and the mass of your person is given in pounds, you have to do a kilogram to pound conversion somewhere in that problem. Just make sure that your units cancel out. If you make sure your units cancel out, you'll be fine.
In this example problem, I need to determine the dosage that or the amount of gallamycin that I need to give to this size cow. In dosage problems, you always want to start with your dosage, so I'm putting 12.5 milligrams over kilogram at the beginning of my math. Now, in order to figure out how much to give this size cow, I need to eliminate the per kilogram in my dosage. I do that by multiplying by the mass of the cow. By multiplying by the mass of the cow, I come up with 5,200 milligrams. Now, I've also written it as 5.2 grams, but you see that it says what amount. It does not specify a particular unit, so you're allowed to choose what unit you would like to use. So here's a problem for you to try. What amount of heparin needs to be given to a 168-pound patient needing 150 units per kilogram? You might look at this word unit and be confused. This word unit is an activity unit that is used for drugs that have varying amounts of activity based on their mass. So what the producers do is they measure what kind of biological activity that this particular sample will have and then give it a rating of units for a certain a quantity that they're giving to you. So if it says 150 units per kilogram, to do this problem, you're just going to write out the word unit and carry it through your math. Now, you will see sometimes unit abbreviated with a capital U. The medical area is trying to go away from that capital U because it is misinterpreted as other units sometimes. So write out the word unit when doing problems like this. So go ahead, try this problem, pause the lecture, and then restart it after you've figured out the problem. To do this problem, the first thing that we do is we write the dosage, 150 units per kilogram. I see that I'm going to need to get rid of kilogram in the denominator in order to go to a certain amount of units of heparin. To do that, I need to multiply by the mass of the patient, but the mass of the patient is in pounds, so I need to either convert pounds to kilogram, or I can convert kilogram to pounds. What I'm going to
Drug concentrations are often given to you in drug conversion problems. The concentration given on medicine labels are conversion factors. For instance, if a label states 200 milligrams per milliliter, that means when you take out 1 milliliter, you have 200 milligrams of the drug in there. That means 1 milliliter of the medicine is equal to 200 milligrams of the drug. That means I can write a conversion factor that expresses this concentration and use it to do a conversion. And you can flip it either way and use whichever one that gives you the correct unit cancellation for the problem that you're doing. This next problem.
go ahead and try this problem. If a patient should receive 100 milligrams of Lasix and the label states 40 milligrams per milliliter, how many milliliters should the patient be given? Pause the lecture and do this problem. To start this problem, we start with the dosage, which is 100 milligrams of Lasix. Next, we recognize that in the problem a concentration is given. This gives me a conversion factor of either 40 milligrams per 5 milliliters or 5 milliliters per 40 milligrams. I need to cancel out milligrams and go to milliliters, so I need to set up my fraction so that milligrams is in the denominator and milliliters is in the numerator. I need to take my numbers, making sure that 40 stays with milligram and 5 stays with milliliter. I enter them in my fraction, and I can see now I have unit cancellation and a fraction that is equal to 1. I do my math, and I come up with 12.5 milliliters.
Here's another problem for you to try. Go ahead and pause the lecture and try to do this problem.
The first thing that we need to do is to give the dosage, make that the beginning of our math. Now, it says twice each day, and some people might have been tempted to put down 0.2. Realize that in dosage problems, you're always wanting to figure out what you are doing at one time, unless the problem says, what would you give over the entire day or something like that. So when you go to do a dosage problem, figure out what it is that you would do at one time, unless otherwise stated. So at one time, you will be giving 0.1 grams. So now what we need to do is to answer tablets, our unit sequence will have to be gram to milligram, and then milligram to tablet. So we set up fractions so that grams cancels out, and we go to milligram, and then milligram cancels out, and we go to tablet. Now I need to make my fractions equal to 1. To go from milligram to gram, I remember that milli is equal to 10 to the minus 3, so milligram is 10 to the minus 3 gram. To make tablet to milligram fraction equal to 1, I need to add 50 to milligram. I do my math and I come up with 2 tablets. Don't forget to do the remaining problems at the end of the chapter, and make sure that you've done all of the in-text problems as you read. There are worksheets that include drug conversion problems and online quizzes that cover all the material in the chapter. Be sure and come for help if you're having any trouble at all.